In E.10.1, we're going to state the sources of primary pollutants and the conditions necessary for the formation of photochemical smog. So what is photochemical smog? Well, that's the smog that's created in the presence of sunlight. And it's generally the brownish colored smog that you would get on a really sunny, dry day in some cities around the world that are sort of in valleys. First, let's start with identifying primary pollutants. Well, how do you know if something is primary? Well, if it's emitted directly from a source, then that's a primary pollutant. So, for example, when we're burning gasoline, if we have incomplete combustion, we'll have hydrocarbons going out the exhaust. So that is one example of a primary pollutant. Secondly, nitrogen oxides. High temperature internal combustion in car engines can form those. And if you make a connection to an earlier outcome, we looked at the equation of where the atmospheric nitrogen would react with the oxygen in this high temperature to create the nitrogen oxides. So from there, we have these primary pollutants now in the air. And so now we have to see, well, what other conditions are necessary that would actually create the smog aspect. So we're going to look at geography and weather. So the first thing we're going to look at is the fact that it needs to be in a valley. So in this picture here, we're trying to represent that with the mountains. You're going to need some sunshine because the sunshine is actually what is going to cause some of the reactions to happen. It needs to be fairly hot and somewhat dry in order for the third point to happen. And the third point is what we call a thermal inversion. And so what will happen here is the pollution will get trapped near the ground. So normally, let's try and understand sort of the chemistry but also the physics of this. Normally we know that warm air is less dense than cold air and therefore it rises. Now what happens sometimes in the mountains is that instead of the temperature going naturally from warmer to colder as the altitude increases, is that actually goes from cold to warm to cold again, and that's why it's an inversion. So what would happen is the cold air can actually come in down the mountain sides and form a cold layer on the bottom. And so this sort of forces the warm air up, but it gets sandwiched in between another cold air layer. And so this is what we call an inversion. And so when the sort of exhaust, our primary pollutants come up, they end up getting circulated a bit within the layer of air that's closest to the surface of Earth. And that will allow for this smog to happen when the sunlight comes out. It can become photochemical smog.